Yes, so my name is Kari Mäki. I'm a research professor for smart energy systems at VTT, and maybe a bit as Heikki was already mentioning about bringing people from energy side, bringing people from AI side. I can clearly say like a disclaimer here that I'm purely from the energy side here. I'm not an AI specialist, but I'm looking at things from the smart energy system point of view. So maybe also in this presentation, maybe setting some ideas, requirements from the application point of view towards the use of AI. And there will be also much more detailed presentations for AI itself following me. I wanted to take here some kind of introduction about where we are at the moment. And actually Heikki was already a bit referring to this in the intro. So of course we are speaking a lot about energy transition. Energy transition is there. Things are going forward very quickly. Of course, always the key driver has been the climate challenge and need of reducing emissions, and I guess we are all pretty much aware of that. But then also there are these two other, how to say, cornerstones that we must also take into account. We must be affordable. We must also be reliable and secure in terms of supply. And exactly this reliability, supply security side has been somehow highlighted in the latest discussions, of course. And so it's important to somehow keep these three things in a good balance always in the energy system. Of course, there are some trends. Of course, we are integrating a lot of renewables in the system. They are very variable. They have a lot of impacts on the system in terms of actually a lot of things, control, protection, inertia, and so on. A lot of things there. The system will also need much more flexibility, controllability in the future. And then sector integration is another big term at the moment. Very briefly saying, meaning like going across different sector borders, energy carriers, trying to find synergies there. And yeah, altogether, the system becomes much more distributed, much more dynamic, much more complicated in a sense. And that's, I think there are a lot of good application spots for AI, more advanced analytics there. And yeah, one fact is that, of course, in the future, or already at the moment, the system will be more and more integrated on different system levels, so that we will see that there is integration happening very close to the customer, but also on the higher levels in the system. And one fact is that data and connectivity, they are already and they will be more and more available, and they can enable us a lot of things, but we need, of course, to be using them in a good way. And as I already mentioned, much more dynamics are there. Not only renewables, but then there are like a different active components, different kind of tariff structures. For instance, EV charging, a lot of dynamics introduced. And what is maybe interesting is that a lot of these dynamics are now appearing also on the lowest level of the system, very close to the customer. And if we think about the existing infra, also they appear also on the areas where maybe the infra is the weakest one. I mean, in the lower parts of the system. So we are seeing very local challenges, but we at the same time we are also seeing very like a high level national challenges, and this is maybe the tricky part. Just very briefly, I would say two key interfaces there. We have energy system in the middle in this picture. We have the challenges, we have the different technologies, we have different use cases, but there are like two interfaces that are extremely important at the moment. Another one is the digitalization, and what is there, what are the possibilities there. I was speaking about connectivity. There will be a lot more about advanced analytics in the following minutes and so on. At the same time, exactly sector integration and certain very important application areas like transport, buildings, industrial processes, then also different kind of multi-carrier system, for instance, hydrogen is gaining a lot of interest at the moment. So these are the two directions that the energy system is currently looking at, and which are like important pieces for the puzzle. This is just to maybe bring another illustration from the European level. It will be very highly interlinked system of systems, and here they also put side by side different networks: electricity, heating and cooling, gas, but also data and connectivity will be there. So altogether, we are going towards like a very, how to say, multi-dimensional complex system. So from the application point of view, what would AI bring there then? So I was also already saying that we have a lot of data, we have a lot of control options already there. And what is important is that we can also bring these things beyond energy systems. So it's actually very important to bring like maybe weather-related data, some behavior related data, something that is totally, I mean, with the first sight, seems totally not connected to the energy system. But there can be some factors beyond energy that are actually very important. And I think we haven't even recognized all of these yet. At the same time, it can also be that we have like too much data. So we have some kind of overflow, which is making it difficult maybe to do the right decisions at the right time, for instance. So a lot of potential is commonly seen within, for instance, data processing, forecasting, detecting different kind of like unwanted behavior or strange events there. Also this kind of multi-vector optimization and decision-making support and so on. But what is really important actually is that the AI and maybe the whole digitalization more commonly, that doesn't actually relieve us from understanding how the system behaves. And I would actually say even that they actually underline this need even more, because with all the measurements, all the connectivity, all the control possibilities we do have, we can also make very like a, how to say, wrong decisions and not proper coordination in case we don't understand what is behind. So it's important to keep in mind that this doesn't relieve us from that need. I was already speaking a bit about potential applications, but maybe there are some categories to go through. I mean, forecasting and profiling, that's maybe I would say the core area of AI at the moment. There are different purposes for generation related data, consumption, markets, a lot of things actually there, and this is already in good speed, I would say. Then a bit related to that, different kind of market optimization, bidding processes, a lot of activities there, and a lot of things also in the daily use already. Maybe a more developing area could be like asset management, condition monitoring, a bit like how to say, more traditional areas for utilities. But combining wide data sets from different sources could be actually really interesting application area for AI as well. Local data processing, where we have like heavy data flows and challenges with transferring or processing that data. I will speak about that a bit more later. And I would say generally on all kind of data intensive services. For instance, for customers, what we can do, for instance, with smart meter data, or through the, for instance, through the new data hub platform and so on. So this kind of, when we are crossing a lot of data, there can be a lot of like potential there. This is our common view. I'm not going everything through here. I was already speaking about some of those. But basically, if you start from the generation side, you can look at the grid operation and maintenance. You can look at the demand side, whether that is EV or whether that is industrial side or whatever. So there are a lot of cases actually there. Yeah, there may be a bit like a new conceptual thinking, so to say. So we see that there are like 3 dimensions that are more and more merging within future energy systems. So we see that these time horizons, they are more and more overlapping. I mean, the traditional world where we had the investments and then we have the operations, that is maybe not as valid anymore. So these are more and more overlapping. They are more and more using the same models and same tools. And actually the operational planning time step is getting quite important, where we are speaking about, for instance, planning the operations for the next week. That can be very important, or next day. That can be very important for the near future. And I think that AI is able to support long-term planning, this kind of decisions, also operational planning quite nicely. Then if we go to operations, through operations, I'm not actually myself sure about very time-critical operations. How good that could be there, but maybe we will hear more about that also today in the later presentations. But here, one critical factor is whether we are speaking about historical data or are we looking at more like data streaming, and so what is our time horizon in a sense? A couple of other, the 2 other dimensions. So we are at the same time going very much across different sectors, and we have seen that data could be some kind of bridge builder in between these sectors. And actually AI is exactly like a tool that could be combining information across sectors and maybe teaching us about what are the behavioral linkages between these sectors. And I would assume that if we look across certain sectors, there can be some like impacts across them that we didn't expect, and maybe AI could be exactly the way to identify such things. Third one is about system levels. So I was already speaking about this. So we see more and more things happening on the customer level, on the local systems, and on the other hand, we also have the high level whole system operations there. So maybe we could bring more AI on the edge level also for local decisions. And this is something we have been thinking about. So I took here a couple of facts about this. So about the more distributed architecture. So we know that in the current energy system, we have a lot of devices around our networks that are providing us actually huge amounts of data, and they can do that also with very high resolutions. But on the other hand, we are currently losing most of this data, if I may say so, because we are of course filtering, aggregating, getting average values and so on, because we don't have just the real capacity for processing all the data as we would get it. So, and of course we are at the moment we already find the most essential information out of that. But on the other hand, we have been asking, are we also at the same time missing something that we could see from the full resolution data? So some kind of question in our activities has been that should we bring AI towards the edge level and to be able to process full resolution data streams and provide very early indications there, a bit like live in a sense, and maybe even in the future take some control actions based on that. And so this is very simple in this picture, of course, but we see that we could do some kind of time critical real-time computing stuff on the edge level. We could use there like more probably full resolution data, and we could maybe predict, for instance, faults or some other events there. But at the same time, we also do have the cloud level, where we are also combining data from different sources. We also see a lot of need for AI also there in terms of combining data and finding the consequences there. So, so that is something we have been working. We have been at VTT. We have been speaking about this kind of edge grid bot concept, which we are also at the moment developing further. But our idea exactly is that maybe we should go towards the case of bringing this kind of edge level. Maybe we will start like a primary substation if we speak about electricity network, maybe someday even secondary substations, and do some kind of live analytics there. So that is what we are working on, and I guess there will be something a bit later more from our side on that. I took also a couple of other examples. So we have also been developing this kind of generation capacity forecasting tool. We did use some machine learning solutions here, and another thing is another concrete example is what we have already in our campus in Otaniemi in Espoo. So we are already collecting a lot of data from buildings. We have the digital twins, and there we have actually had already for some years AI and machine learning running in the background, adjusting our parameters, learning for the models and everything, and actually very exciting stuff going on there. And also our new building, our new headquarters in Otaniemi. These are of course part of that, integrated into this kind of platform, and this is also for us like a living lab for this kind of development. Yeah, that brings me to the end of my time slot and also my presentations. So some conclusions just to very briefly summarize. So of course I was looking from the application point of view. So AI as a means, not as a target itself. I think data, we are utilizing research in the research world, for instance, but more in the daily operations is possible. And maybe one point is that where is the value really? So there's a lot of discussion, of course, around renewables and EVs and so on, but also the more traditional fields like asset management could really benefit from AI. Yeah, at the end, we need to understand the system. We need to be able to make the right questions as such, and then see if AI is able to provide us answers into that. Thanks. That was very, very brief overview.